Find the equation of a tangent line to the parabola y equals x squared at the point 1, 1, right? And so there's some concepts in here that really have a little bit to do with this, but actually have more to do with, this is something that your calculus teacher, whoever it is, will complain about next year when she says, come up with the equation of a line, and you're kind of saying, what? But you know how to make the equation of a line, right? A line is given by y minus k m times x minus h. Or I should probably say it like this. Let's go like this. Y minus y1 equals m times x minus x1. That's probably more like what we've done before, right? That's called point slope. Right? So what do you need in order to come up with the equation of a line? You need 1 point, and you're going to need the slope. Okay, now we need to, now we're going to use the stuff that we're learning here to figure this out. Y equals x squared. That's a pretty basic parabola, right? 1, 2, 1, 2, 1, 2, 1, 2, 3, 4. Right? It has the points here, and here, and here, and here. And I'm probably not drawing that very well, but that's what the graph looks like. What do they mean by a tangent line? What does a tangent line do? Touches it at one spot and it keeps going. In order to make this the best tangent line that I can, I'm going to use this. I could use like that. I'll make it a pretty thin line. I'll even make it a different color. So that's what we mean by a tangent line, and it's tangent at that point 1, 1, right? So necessarily, that line is also going to intersect down here. Now, where's the focus of this thing? Where's the focus? The focus should be somewhere in here. We don't know exactly where it is. But here's the thing about this. This is where I messed up last class. If we look at this picture here, this is all about the reflexive properties. We would expect that if you have like a beam that's coming into this thing like that it should be reflected over to the focus. And we would expect that this angle and this angle are the same angle, because that's like bouncing the pool ball off the cushion, right? So this angle, and in the book, if you look at their picture, which I'm sure is better, is they're calling that alpha, and they're calling that alpha too. They're equal, same angle. But here's, this line here is parallel to the dashed line, correct? Because this is a parallel line, that's straight, which means that these two angles are corresponding angles. And we know when you have parallel lines in a transversal that the two corresponding angles, they're congruent. So if that angle is alpha, so is this angle is alpha too. So let's see. If I draw that a little bit bigger now, we know that this is alpha and this is alpha, which makes that triangle what kind of triangle if two angles are equal? It's an isosceles triangle. Right? And the opposite sides have to be equal. Okay. So let me see. So let's see. We know what this point is. That's 1, 1. Can we figure out what the focus is? And we know what the vertex is, don't we? The vertex is right there. That is 0, 0. So couldn't we find the P based on this equation right here? No. What is it that's 1? It's not P. It's 4P, right? So from this equation, we know that the 4P equals 1. So what does P equal? equals 1/4, right? So we know that this point right here has to be 0, 1/4. Okay. We also know that because these two angles are the same, these two sides are the same, that whatever this distance is, that's exactly the distance here. So we can use the distance formula between these 2 points to find this, and then we can find that distance straight down, and we will know another point on that tangent line. And then we can use that to find the slope, and we already have a point 1, 1. So distance formula, d equals the square root of 1 minus 0 plus 1 minus 1/4 squared. D equals the square root of 1 plus 3/4 squared, which is the square root of 1 plus 9/16. D is the square root of 16 plus 9 over 16, which is the square root of 25 over 16, which is 5/4. So that tells it this distance is 5/4. That means this distance is 5/4. Okay, if you go straight down 5/4 from the point 0, 1/4, what point do you hit? What is the y-intercept? Right? Subtract minus 5/4. 1/4 minus 5/4. -1, right? So this distance here has to be 5/4. Or you say -5/4 if you want, which makes this point 0, -1. Okay, now that you know 2 points, find the slope. M equals y2 minus y1, 1 minus -1, divided by x2 minus x1, which is 1 minus 0. So that line has a slope of 2 over 1, which is 2. So now we can plug in that this y minus y1 equals m times x minus x1. I'll let my x1, y1 be 1, 1. Y minus 1 equals 2 times x minus 1. Y minus 1 equals 2x minus 2. Y equals 2x minus 1. That's the equation of the tangent line. Okay, that was a long one.